Welcome to the Real Python Podcast. This is episode 176. What fundamental developer skills are new Python users missing? And what best practices are developers from outside a computer science background lacking? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. Christopher opens up our discussion by sharing a recent social media thread about teaching software engineering best practices to scientists and others without a computer science background. We talk about software design philosophy and sharing knowledge within an organization. We cover the results from the 6th annual official Python developer survey. The survey covers Python usage, language versions, frameworks, libraries, and various demographics. We dig into the details and share our insights. We also share several other articles and projects from the Python community, including a couple of release announcements, so many Python data frames, speeding up your code when multiple cores aren't an option, Python's syntactic sugar, a computer algebra system named SymPy, building a blog in Django, code metrics in Python with Radon, and a TUI app for daily writing. This episode is brought to you by Snyk. Snyk helps Python developers stay secure without slowing down by providing real-time code scanning and actionable fix advice right from their IDE. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
We're here to dig into some more articles and projects and a couple pieces of news and, the results of a survey. So do you want to dig into some of that stuff?
Yeah.
Okay.
For sure. So first chunk, both of our news bits are release things. Django 5 is now in alpha, which is their feature freeze. A couple interesting little things in there. So fields in forms are now built using a template, which means you can override it. This clears the way for better reuse with heavy styling frameworks like Bootstrap. So this is something that I've kind of been looking forward to.
Good.
They added a couple new database features. You can now tie the generation of data like defaults and virtual columns into your models. So this kind of pushes the ability of filling information into the database side. This is useful for folks who are using Django to wrap existing tables rather than, straight Django stuff, or if they're sharing them with folks who are, say, doing reporting or something along those lines. So it essentially gives you a little more flexibility along those lines. And then the big, there's a bunch of internal things going on as well. They've bumped the major number because they're dropping a bunch of Python support so that they can clean up old code and dependencies.
You know what version it starts with?
Yeah, Django 5 drops everything before 3.9. So it starts with 3.10, 3.11, and 3.12.
Okay.
So 4.2 is going to be the last series that supports 3.8 and 3.9. And of course, there's an LTS in there as well, so you can stick around if you want. The other release is the official announcement of Mojo on Linux. So you might recall us talking about Mojo back in episode 157, which was way back in the spring. It's a superset of Python with a focus on compute performance. They're rolling this out in stages. There was an early access program for a while, but now it's actually out for Linux.
Yeah.
There are releases for other operating systems coming. But if you don't want to use their online playground and you've got Linux, you can now muck around locally. And I'm starting to see, I was starting to curate next week's newsletter, and I'm starting to see articles on is it faster? What if you use Numba? And there's stuff like that coming very quickly as people are digging into it. So it's interesting to see.
Yeah, getting a chance to play.
Yeah. The one article that's going to be in a future issue actually, if they use Numba one way without a certain flag, Mojo was faster. But if they used it the other way, Numba was faster. So it kind of falls out in the wash. So that was kind of interesting to read about. So maybe we'll talk about that a little more in another episode.
Yeah.
And then not quite news, but something that's been around for a bit. So for the last 6 years, there's been an annual survey of Python programmers. The results for 2022 have just been published. It takes them a while to get all the data massaged and out into the world.
Yeah.
The survey asks questions about, how we use the language, how often we write in other languages, the tools we use, and that kind of stuff. So as usual, there's some very predictable things and there's some surprises. So, for example, the first question asked about primary and secondary languages. 85% of respondents said Python was their primary language. Of course, it's a Python survey, so you would expect that. The three most common languages after as the secondary language were JavaScript, HTML, and SQL. And all were very close in results, around 36, 37% kind of thing. Interesting twist on the same question was what happens if you categorize it by data science folks and web folks. So for data science folks, SQL becomes the number one secondary language with 45%. So it pops up a lot more.
Yeah.
And similar for within the web folk world, JavaScript becomes the secondary language of 66%, which kind of just makes sense. And I guess that means 66% of Python web developers are frustrated. Sorry, I can't help not poke at JavaScript. Have I mentioned how much I love HTMX? It means I write less JavaScript.
There you go.
Yeah, anyways. So that's what we write along with our Python, but how about what we do with it? A whopping 51% of respondents said they do data analysis, while 43% said web dev, 36% machine learning, 34% said DevOps. The thing I found most interesting about that 51% saying data analysis response was only 34% of folks said they considered themselves data scientists.
Yeah.
So there's a whole bunch of us that are doing data analysis without it either being our real job or we don't feel like we're worthy of the title or something along those lines.
It's not sciencey enough. It's
not sciencey enough, I guess.
Businessy.
That's right. It's right. Summing a column does not make you a data scientist, I guess, is what it comes down to. So,
all right.
There was a question about Python 2 versus Python 3. For the last 3 years, the answer has been pretty consistent, hovering around 5% of folks doing Python 2. My condolences. Number is slightly higher this year, but likely due to variation in respondents rather than an actual uptick in usage. Of the Python 3 folks, 45% were using Python 3.10, and that was the latest interpreter at the time of the survey. So almost half of folks are basically using the latest and greatest. Next question is on where you go to get your Python. 37% get it from python.org. That number goes up to 52% amongst Windows users. So
yeah.
It's primary source. About a quarter are getting it from a operating system tool like Yum or apt-get, Homebrew, those kinds of things. For some of those secondary sources, it's 17% for Anaconda, 17% for Docker, 16% for PyEnv, which statistically is basically the same. And a paltry 6% of folks build it themselves. Virtual environments, 49% are on virtualenv, 31 on Docker, 22 Conda, 16 pipenv, and 14 on Poetry. Poetry's been growing over the last couple of years, so that's actually been sweeping upwards.
Yeah.
Interestingly, 23% said they aren't using any, which means none as an answer beats everything but virtualenv and Docker. So there's more people not using it than using Poetry. Almost more than Poetry and pipenv combined. Not quite, but almost there.
Yeah, we talked about that. A lot of people are they have their main environment and that's where they do everything.
Well, and if you're, I find when I'm coding things for real Python, I have one virtualenv for all of it. I very seldom run into anything where I'm duplicating anything. And so, I don't have to keep creating all of them. And if that were my only job, I probably could get away with not having it. So
yeah, we'll probably talk more about that.
Except I code on a Mac, so I'd have to have it in order to get out of Python 2 world. But that's the only reason. So there were some other questions about frameworks on the web. Flask and Django were both at 39%, and followed closely by Fast API at 25%. So there's almost a three-way horse race there. One that I was a little surprised on, maybe it's just because I don't use it, but PyTest beats out using the built-in module by almost twice. So more than 50% of folks use PyTest in their testing. So I'm always stuck to the old thing. Unit test has always been good enough for me, but I guess this is popular. Other popular libraries, almost half of people are using requests. 29% Pillow, 25% async IO. So again, not a lot of surprises there.
Yeah. Lots of GUI frameworks in there.
Yeah, little bits and pieces there, yeah. There were some questions about cloud usage. Almost 50% are using AWS, and in doing so, almost all of those are using containers. IDE-wise, 39% VS Code, 29% PyCharm, and a lonely little 3% like me on Vim. I was happy to see that it beats Emacs, though. So there's that. Interestingly, only 14% of people said they use a single editor. 11% they were using 5 or more in development. And I can't wrap my head around that. I have a hard enough time.
How do you remember all those key combos?
Well, that's it, right? Like I have a hard enough time. I always hit escape in PyCharm because I'm trying to be Vim inside of PyCharm. Right. And I just can't imagine how you build up any muscle memory with 5 editors.
Yeah, 5 plus.
5 plus, yes. It's crazy. So last little chunk is essentially on demographics. Spoiler alert, my friend, you and I are old. Biggest age cohort was 21 to 29 with 37% of respondents. Maybe it's just young people have more time to answer surveys.
That's it.
Yeah. Only 9% of folks like you and I are over 50. So we're dying off, I think, is what it comes down to. So anyways, the most common experience level was 29% of folks having 3 to 5 years in Python, which kind of matches the age range. So that it sort of makes sense. But the biggest group of folks had less than 1 year of professional coding experience. So we seem to be trending young as an industry. So maybe that has to do with Python's growth, right? So I suspect if you did the same thing with Java people, that's what we should do. We should start a Cobalt podcast. We wouldn't be the 9% then. We'd be the 80%. And there'd be a bunch of 80-year-olds who were there to talk to us.
Well, I think the professional thing is an interesting word too, because it could be, people that are using the language in other ways and are now they're considering themselves professional, which is something we'll talk about too.
I suspect when you start talking about, almost 30% of folks having 3 to 5 years in Python, that probably means I picked it up in university and now I've been coding for a year, getting paid to code for a year, right?
Yeah, that's true too, yeah.
So it's always hard with this kind of stuff, right? Like, so I have been getting paid to code one way or the other since I was 16. It wasn't a full-time job. If you asked me at 17 when I was occasionally getting paid to write somebody software, whether I was a professional, I probably would have arrogantly said yes. I mean, no. So like,
how do you get paid for it?
Right? Like, when do you tick that box? Right? I don't know how that works, but and then sort of somewhat related is a breakdown of job roles. So 65% of folks report as being a developer/programmer, which kind of makes sense. But only 19% said they were data analysts. And that feels to me like it contradicts the fact that 34% said they were data scientists. So I don't know how that goes together. I suspect some of that has to do with the job titles and square pegs and round holes. But anyways, I find all this kind of stuff fascinating. There's lots of little goodies in here. You can get at both the raw data and the historic data of all 6 years.
Yeah.
If you want to go and do some neat visualization and get yourself some Twitter likes or something, I'm sure there could be some cool stuff you could do with this. So go play.
Yeah, definitely. Do some data analysis on it.
Yes. Cool. Yes. Whether or not you're a data scientist.
Yeah, exactly. All right, well, we'll dig further into some topics here. My first one today is about data frames, and the title of this one is "Why Are There So Many Python Data Frames?" It comes from the Ponder blog. I've mentioned this before. There was a Matt Harrison piece that I think came from Ponder, and this one is from Mahesh Vashistha, and it is kind of mostly a thought piece. He's asking lots of questions, like, again, starting with that whole premise of why are there so many of these different types of data frames, and also sort of commonalities between them. And he mentions the ones that we've mentioned a lot on the shows, things like pandas and polars, but also rapids and cuDF ibis, something called Snowpark, which I'm not familiar with, Dask, which I've talked about on the show, but also then other large data things like PySpark, Daft, and BigQuery data frames, which again, I'm not that familiar with. it really tours these concepts with a handful of questions. And he really wanted to sort of conceptualize what's happening. Number one, there's 4 ways that data frames can be conceptualized. That's one of his first kind of concepts. The first is, to think of it as a spreadsheet. Spreadsheets, again, we've talked about this a lot on the show, the idea that they're much more usable by non-programmers, things like Excel. In a spreadsheet, you're doing in-place updates. They're implicitly eager, meaning that there aren't things like lazy kind of methods that can process data later. It all happens at the time that you're entering and modifying things. It maintains its order across time, unlike things like pulling a SQL call where things might be a little different in each session that you do. You can pivot or melt the data and reshape it. And then typically the data sits on a singular machine and isn't really like networked out. Very useful in the world of business intelligence and plotting and so forth. His other way that a data frame could be conceptualized is as a query or a part of a relational database. And the tendency is that you build up these sort of query trees. There isn't really a notion of specific order. The data that you start with is typically maybe big for it to all be on one local machine, but you can materialize like a subset of that. And typically you're querying it with SQL. The next one is in 2D arrays or matrices. These are blocks of values. Think of like NumPy, the series and so forth. And they're useful for stats and they're mutable. The rows are ordered, which is something we're going to focus on a little bit in this thing. There's no specific column or row labels, but you can do lots of transposing, adding, multiplying, and definitely your things you're doing in machine learning libraries, like things like scikit-learn and PyTorch. And the last is to think of data frames as objects, and that's how Python users normally see them, and literally naming things as a data frame. And these objects then have lots of methods for viewing and transforming them, and how people typically write maintainable data transformation pipelines. And so if you're going to do a lot of wrangling with the data and especially, do Python type of stuff. So the other areas where he kind of digs into in this article, I think are really interesting too, where he's looks at these data frame libraries and says, okay, each one of these is designed at slightly different purposes. And key things that he's interested in is whether rows are ordered or maintain that order, whether the rows have labels, and then whether there's eager or lazy execution. And then kind of gets into this idea of, is there a separate engine that does the computing, where Ponder is a product that kind of does a lot of SQL. It kind of takes pandas like methods and allows you to apply them directly to the database. It kind of is like a translation layer in a way. It's an interesting tool. And so hence why they're doing this blog post explaining some of these ideas behind it. So he drills into these ideas and these questions like, okay, well, should a data frame have row labels? And I don't see this as big of a problem, but it really depends on what you're trying to do. Row labels, for me, very often are just could be just a field. They don't necessarily have to be like indexed the way that you can in pandas, but he has lots of use cases and drills really deep into that. The other one that I think is interesting as a question is, should data frames be lazy? Eager evaluation is when code is evaluated as soon as you run the code. And then lazy evaluation is where you're running lines of code, and it means that the underlying logic is added to like a plan or a query plan rather than being like directly evaluated. This has come up in multiple times of talking about polars, and that's the example that he uses here. It allows you to do certain things, but it's a very different kind of behavior. It has advantages when you're dealing with really large sets and things like that, getting this ability to choose when you run the lazy data frame. To kind of conclude a lot of these thoughts, he acknowledges the complexity and how diverse these data frame libraries can be. He invites the readers to kind of check out Ponder and its pandas-based Python data frame library. Interesting how, again, it does this translation of Python queries into multiple sort of SQL dialects to work across these databases. And the thing I liked about the article at the end is he had lots of footnotes where he referenced where a lot of these thoughts were kind of coming from. I talked in episode 167 with Mark Garcia about exploring Pandas 2.0 and how Apache Arrow is becoming a part of that. At the time, we discussed this thing called the data frame Summit, which the Python Dataframes Summit 2023 was held in Basel, Switzerland this summer. It actually was right before Euro SymPy conference. And Mahesh attended that. And so he was thinking about these things while he was, he says, floating down the Rhine in Basel and thinking about, data frames and so forth before attending the summit. So if you're interested in thinking a little bit deeper on data frames and finding your best use case, this is a really nice survey on that. There are a ton of ways for malicious actors to get into the systems you build, like SQL injection, arbitrary code execution, and out-of-bounds writes, just to name a few. Luckily, you don't have to be a security expert to keep your apps secure. Snyk is a developer security platform that helps you secure your applications from the start. And Snyk does it all right from the existing tools and workflows you already use. IDEs, CLI, repos, pipelines, and more. So your work isn't interrupted. Start your free Snyk account at snyk.co/realpython. That's SNYK.co/realpython. What's your first one?
So I've got another Idemir Turner Trauring article.
Okay.
We've hit on this a couple times recently, but evidently he's writing a book on performance tuning. So this is why he's pumping out these articles he's coming up with topics and summarizing things. This latest post is called Speeding Up Your Code When Multiple Cores Aren't an Option. So his goal in the article, as well as in the book, is to teach the kinds of optimization techniques that are often used in lower level languages like C and Rust, but some of them can actually apply to Python. And so, for example, what he does here is he starts with a chunk of code that converts a grayscale image into a black and white one through a dithering algorithm, and then progresses through it, trying to make it faster and seeing, what it means to do that. So if you haven't done image processing stuff before, the short version of how this works is you can think of all the pixels as being a big matrice. And most image processing, you're looking at a pixel and looking at the pixels around it and then doing some math on the pixels around it, like averaging them or, doing things if they're over a value or under a value, whatever. And this kind of mechanism works for all sorts of image processing. And that's the algorithm that he's using here in order to do the grayscale to black and white thing. As you can imagine, this means looping on all the pixels in order to process the entire picture. And one of the challenges with this kind of algorithm is because a pixel's value is based on the other pixels around it, including the ones that have and haven't been processed yet, you end up with this interdependency, which tends to make parallelism hard. Because I can't just chop the work up because any row is dependent on the previous row's results. And normally how you chop things up is you don't want them to have to know about each other. There are ways around that. He doesn't get into that in the article, but he's just using this as an example of somewhere where throwing more cores at it doesn't necessarily make things faster. So he's built the base algorithm on top of NumPy, using an 8-bit array of integers to represent the 400 by 400 picture. And then just because you can, he throws the numbajit at it to get a bit of performance boost, and that's his base. So it's pure Python, not counting the numba and numpy, but there's no C or Rust or extensions or anything going on. His first pass essentially just loops over the pixels, does that calculation I was talking about. There's a little bit of boundary checking inside of it. And because the way the dithering algorithm can work, the answer to a pixel might actually be bigger than the 8-bit range. So he uses 16-bit integers and then squishes them to make sure that the final answer is within the 8-bit range. So all told, that takes 2.3 milliseconds to perform. And then the rest of the article essentially is how can we do it faster than that? There are 4 concepts that he introduces and then goes through and tries to apply those 4 concepts to the algorithm. The first one is what's called instruction level parallelism. So there are certain operations on your CPU that can do more than one thing at a time. And if you can get your code to be using those instead of the ones that don't, things are going to be faster. The second concept is something called branch prediction. So you've got an if clause in your code. When the computer processes it, if the if is true, it can continue processing the code. But if it's false, the CPU has to jump over that conditional block, right? So you're having to move around the processing order. So modern CPUs pipeline instructions. That means they are trying to do a bunch of things at the same time. And if you jump over the code, that pipeline is useless. It has to be reset. And of course, this takes time. So the CPU has a little prediction algorithm when it sees one of these branches, and it tries to figure out whether or not it's going to have to jump so that it can populate the pipeline properly. So this is called branch prediction. And if your branch prediction is incorrect, the CPU made a wrong guess, then your code takes longer to run. So there's two ways of dealing with this. You can make it more likely for the branch prediction to be correct, or if you can get rid of the jumps, then there aren't any branches, and that alleviates that problem. The third concept is called SymD. That's short for single instruction, multiple data. There are CPU operations that work on vectors of data at a time. So let's say you've got two sets of numbers that you want to multiply together. Instead of looping over them, you might be able to create up like two stacks of them and then use a single SymD multiply instruction to have them all multiplied at the same time. So your compiler and your CPU try to decide when to use these kinds of calls. And as you can imagine, one SymD instruction is going to be better than multiple multiplies. So again, if you can get your machine to do this, then it might be faster. We briefly talked about this a couple episodes ago when we were talking about optimizing NumPy and whether or not it was compiled for these kinds of SymD instructions on your machine. So this is the same kind of concept there. And then the final idea has to do with how your CPU caches things. So reading and writing from memory is actually significantly slower than just processing on the CPU. Every time the CPU has to go out to get something from memory, it slows things down a lot. In order to try and help with this, your CPU has caches. Depending on your processor, that actually might be 2 or 3 of them. And if the information, whether it's the code or the data, is in the cache, then it's a lot faster than having to go out to memory. So you want to try and make sure that the stuff you're operating on is local and coming out of the cache rather than having to go to RAM. And that can make a significant difference in your processing. So the rest of the article essentially takes the base code and then those 4 concepts and goes through it chunk by chunk, trying to say, hey, okay, let's consider the branches. We've got a bunch of branches here. Can we get rid of some of them? And if we do, does that help? All told, by the time he's done, it's still just Python, but he's got 7 different variations, and the final variation is 4 times faster than the first one. So that's without going to extensions, that's without going to parallelism or anything along those lines. So if you want to take your optimization skills to the next level, this article is a great place to start. And if the book is like this, I'm very much looking forward to reading it. It should be very, very useful.
Yeah, it's funny. He has a link for it, but I'm trying to find the title, what it's going to be called.
The link's a waiting list link, so he may not have decided yet.
Yeah, okay. Yeah, the first line of it is Python gives you fast development and slow code. And so that's literally his site has always been focused on this. It's titled pythonspeed.com. So
yeah, and he's a fairly good writer.
Yeah,
like I always find his articles easy to process, even though he's talking about some fairly in-depth stuff, which is good. It's what you want your authors to be.
Yeah, definitely. All right. Well, I have 2 kind of things I want to summarize, just kind of give an idea to people about these 2 pieces. Because one, I've talked about a lot on the show. It's an article by Jake Edge on LWN, which covers Linux and other free software community stuff. Used to be, I guess, Linux Weekly News, but they've expanded it quite a bit, and now it's just LWN.net. Jake has been the one who's summarized the happenings at the Core Developer Summit in the past couple of years. And the article is called Python is mostly, those are in parentheses, mostly, made of syntactic sugar. He dives into Brett's series on syntactic sugar, which I've talked about a lot on the show. And then he also references his latest talk that was at PyCon 2023, which was kind of wrapping up the whole series. For reference, Brett's been on the show several times, and I was very interested in the subject, and so I'm not going to spend too much time digging into it, but he was on in episode 47 where we first kind of talked about this and talked about the idea of unraveling the syntax of Python to its core, and then continuing to unravel it like a year later in episode 92, and then right around PyCon this year, episode 154, we started to focus on WebAssembly and then the kind of end result of this of distilling a minimum viable Python. So those are good references if you are interested in this idea. What I like about this piece is that it does a really good job of summarizing all these concepts and kind of putting them together and explaining it in a slightly different way with some examples of code that kind of build on top of each other. The early posts from Brett's blog went really deep, and he was truly like unraveling the Python syntax and showing the code disassembled into C code, and spent much more time kind of under the hood. But as he went through every element of Python to kind of discuss it, the later ones started to gloss over some of that disassembly stuff, and it kind of got a little harder. So if you were picking and choosing from different ones and didn't go from the beginning, I think you might not have gotten as much out of some of the later ones. I think it was kind of a combination of like he was eager to complete the series in some ways. So this is, again, a review of his PyCon talk and the series. If you're interested in the syntax of how Python functions, there's a quote from it that says, programming languages are made up of a mostly irreducible core, things that you can't reduce any further, with lots of sugary constructs sprinkled on top. And that's the syntactic sugar. And so he was able to find these core 10 building blocks as he kind of had worked it out, that you have to have these in order to kind of build all the other constructs inside of it. And as he was explaining in my interviews with him, even things like a simple symbol of or operator like minus is underneath it, made up of this. You can do plus if you have minus, and you can do, so forth, and you can kind of keep going from there. One of the things that I focused on when I was talking to him is on the why. Like, why are you doing this in my conversations? And much of it, was trying to figure out like how small he could make Python, the idea of this sort of minimum viable version of Python. And that was related to this work that he was referencing in some other blog posts of, well, how can we get Python working with WebAssembly? And he's continued that quest of working with WASM and WASI. He's really deeply involved. He's actually making sure that Python is compiled to those targets of WASI and WASM. And we discussed that in real depth in our last conversation. So what I, again, like about this particular Jake Edge post is that it, again, sort of summarizes everything and takes you through that idea of what is the core of Python, and then how does the syntactic sugar on top of it sort of explain kind of the constructs of what are happening in it. So it's an interesting kind of summarization of all those ideas into one place. The other article I wanted to mention was something that, as Chris and I were kind of going through and picking our articles, I got a little confused. And I think this happens to a lot of people that look at the namespaces of Python and packages and confuse things like PyPy and PyPI and so forth. And the article was titled "Towards a New SymPy," and it was spelled SYMPY. Now, I was familiar with a different SymPy, which is SIMPY, which is designed for doing simulations and setting up experiments. And I had studied that a little bit by helping with a video course that we'd put up on Real Python. And so I was familiar with that. I was like, oh, this sounds kind of cool. And again, I confused it with its actual name here, which is SYMPy, which is more kind of symbolic Python or symbolic math. And so that confusion, I feel for other people who have done the same thing on lots of other naming things. There's only so much you can do. But this is by Oscar Benjamin on his blog. And currently this is the only series that's there on his blog. He's starting this multi-part series digging into SymPy. I was eager to kind of learn some of what's happening with it, but I learned very quickly that this is at a much higher mathematical level that I kind of wish David Amos was here, because this is totally his kind of jam. So if you've been wanting a very mathematical article to dig your teeth into and how Python kind of intersects with that, his goals for the article are to describe the issues around the speed of SymPy currently and share his work that he's doing to sort of speed it up recently. SymPy is trying to address the limitations of floating point numbers, and we've talked about that from time to time, that there are a lot of situations where the resolution of floating point numbers are just not going to be acceptable. Small errors can accumulate and become really large errors. To solve error accumulation problems, calculations need to be done with precision that is higher than a lot of the machine precision floating points numbers can allow. And then some calculations can only be done reliably unless they're done like exactly. And so SymPy is more of what's called a computer algebra system. And so it's going beyond floating point numbers into symbolic math. And he shares these examples, digs into each one of these things of, okay, well, how would this look if we're trying to solve something with machine precision floating points or having an arbitrary precision floating point? Things like saying, oh, up to 50 places or something like that, or a robust floating point calculation. And then he gets into these exact numerical calculations. I thought it was a really fascinating tour into this stuff. He himself is writing it with the intention that he wants it to be accessible for someone who's not a SymPy developer, but he also wanted some other SymPy developers that, hey, you are my intended audience, and I want you to understand some of these points I'm trying to make about how to speed this up. So again, a fascinating tour, but I think you might, if that's isn't your background, you might be jumping into several Wikipedia articles, which I definitely was when I was consulting the different concepts covered. So I learned a bunch, and it definitely is something that I'm going to keep an eye on for the future now that I know a little bit more about what SymPy is. This week, I want to shine a spotlight on another Real Python video course. This course is titled Filtering Iterables with Python. It's based on a Real Python tutorial by Leodanis Pozo Ramos. And in the course, Real Python instructor Nagar Vahid teaches you how to use Python's filter method in your code, extract needed values from your iterables, combine the filter method with other functional tools, and you'll practice using list comprehensions, generator expressions, and exploring techniques for writing more Pythonic and readable code. I think it's a good investment of your time to learn how to use the filter method effectively in your code. Like most of the video courses on Real Python, the course is broken into easily consumable sections. You get code examples for the techniques shown, and all courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. What's your next one?
My next one's by Simon Wilson, who is the creator of Dataset, which is a data exploration tool. Article isn't about that, though. It's called Building a Blog in Django. Simon decided that Dataset needed a blog, and being a good maker, rather than use something someone else built, he decided to roll his own. The article's part article and part code dump. It essentially has all the code you need to add a blog to an existing Django site. So if you've never done Django before, this isn't the place to start. But if you have done some, it's a practical example with sort of some light explanations along the way about what all the parts do and why some of the decisions were made. Each blog post is an object. It's got a title, a summary, a body, publication date, optional info about the author. Supports both live posts and drafts, indexes, Atom feeds, RSS, all that kind of good stuff, as well as having a bunch of meta card info because, Twitter and Mastodon and all the other socials want that to do healthy posts for a link. So the article talks about the different database models, what you need to store. It mentions that he actually wrote the code using ChatGPT as his first pass at it and then modified it. He doesn't say how much modification that actually took. Maybe that's a separate, I can go poke him and get him to write a separate article, how useful that was.
Yeah.
But after the models are in place, you have to go off and do the views. There's about a half dozen functions that correspond to the pages in the project. And yes, he uses function views rather than class views. sorry for non-Django people, that's kind of like tabs versus spaces, Pepsi versus Coke, and VI versus Emacs, which I think I expressed my opinion on that earlier. Anyways, the Atom feed uses the feed class from the syndication framework feature of Django. I've never used one of these myself, but it's actually really simple. Creating a class, does a query into your system, and registers an instance against a URL. So like 10, 20 lines of code, and your Django site does RSS based on any one of your models. So it's a quick and easy way of putting that kind of stuff together. And that kind of is sort of one of the bits of meat of this article. It takes very, very little to do something that, there are commercial products out there that do almost all of that. And this is, a few hundred lines of code. And then the last chunk shows you what you need to do to your page templates to get that meta tag info stuff that I was talking about for your social pieces. So you can tell Simon's a good developer by the fact there's automated tests included, and they take up about as much code as the code they're testing, which I find is pretty typical. You usually end up with about a 1-to-1 ratio if you want good coverage. So this is part of Simon's Things I've Learned blog, which is a rather rich vein to go mining. He's got lots of stuff like this. So even if the Django post doesn't interest you, you'll likely find something else there you could learn digging around. So I definitely recommend taking a look at his site.
Yeah, he's a good follow on Mastodon. He's often talking about large language models and doing lots of experiments with them. And I'm hoping to get him on the show sometime to kind of discuss some of his findings and ways that he's using things. And maybe I can ask him the questions you're talking about of like, doing that first pass of generating the code. Well, I think that takes us into our discussion this week.
Yeah. This is based on a Twitter, I'm still calling it that, post by Matt Harrison. Matt's a corporate trainer, and he comments that increasingly he's getting students from the data science side, which kind of ties back to what we were talking about earlier. And often they don't have formal training in CS, and he kind of asks, what skills and best practices do you think they might be lacking that maybe he should cover? It's an interesting kind of question. Years ago, I worked at a company that built online gambling sites, and I managed 3 teams of developers, 2 of which were Java folks for the back end of the games, the probability engines, the banking, the reporting. And then the 3rd team were Flash developers, because this was some time back and people still did that.
Yep.
And Flash was for the front end of the games. And this was my first time managing Flash programmers. And it was an adjustment, and very much kind of the things that are being talked about in this thread. So there were like 5 or 6 people on the team, only one of which had done a CS degree. The others were from art and music backgrounds typically. But when it came to coding, we had almost no common vocabulary. They knew their tools well. They made good games. But I'd say something like linked list, and they'd give me a blank look. And in fact, it caused issues on the team because the CS guy was forever trying to build code in the style that he was taught. And Flash doesn't like to work like that.
Yeah.
So he was always locking horns with the other devs. He couldn't understand why they didn't want to make the code more maintainable and readable, and kept cranking out code that wasn't fast enough. And they're just looking at him going, but it doesn't perform. So that's why we don't do it that way. Right. So this kind of cultural thing is kind of fascinating. And so I guess to Matt's question, what fundamentals do you need? And I hate to be that guy. Well, not true. I love being that guy. But it depends, right? Like the first thing you need to figure out is what are people trying to accomplish, right? Well, one of the responses to Matt's question was someone talking about, how to deal with merge conflicts. I'm like, actually, a lot of data science folks never have to deal with this problem at all. Frequently, they're writing one-off scripts. They're the only person touching the code.
Right.
And Git and merge management is important. Yes. To them, maybe not, right?
They're working inside of notebooks and not necessarily ever having things go through, GitHub or what have you.
Yeah. And similarly, there was another comment about code reuse. And I think this is an important skill. And if you're doing a lot of data science, you're going to find you're repeating yourself. So there's places where when you learn how to do that, it'll reduce the amount of code you write. But is it as important as if you're developing software? Probably not. So, is it a skill you could pick up later? Yeah, right. So I think a lot of this sort of is everybody's got a different experience and their jobs are different, right? And you more so than me, you've got a lot of sort of a wider variety of background.
Yeah.
Worked with a lot more kinds of people. Where did you go with this? What did you think?
Well, I want to reiterate the one thing that you mentioned that I saw in the thread too that I thought was interesting. Yeah, the idea of just like creating functions, and not copying and pasting code, which I'm like, yeah, that's not uncommon. People that are writing scripts, they're just like, well, the code's just going to keep walking through and I'll just repeat this. And it's like, well, you could organize it into a function or get more advanced and talk about objects and creating classes and things like that. Again, hence the repeating yourself. But yeah, I have a really odd background, as most people know who listen to the show. But when I got out of high school, I got an electrical engineering, started the program and was learning C, was learning Fortran and the like. But I dropped out, and I was really not enjoying my electrical engineering program at the time. And computers, I know this sounds really weird, but they weren't very interesting to me at the time. So they, what I could do with them at the time, and this is a long time ago, I was like, I would rather focus on what I thought was interesting at the time, which was music. And so I was in a band and toured and did all my whole background and that sort of stuff. But I ended up picking up SQL very late in life. And then I ended up working in a company and not having the background. I still, I was an educator for a while. I was teaching people about digital systems and teaching about binary and teaching about, digital audio and so forth. And so I've always kind of been a deep researcher, and I find myself to like soak in information. So I always sought out these things like, through books and podcasts and articles and of course the internet now. And so I would notice the best practices and think of these things and try to bring them into my workplace. In my SQL experience, I was mostly working by myself, but then I started to work in a company where I started to get into Python. And almost every job I was given, this kind of goes back to the survey that we were looking at. One of the things that we didn't cover is, how big is your company? And then how big is your team? And the majority of them were either rather small companies or, again, rather small teams. And that was kind of what I was in. I was in a small team, and I was kind of doing this sort of support for data scientists and creating automation tools and deploying things internally because of, it was a bank and we weren't allowed to put stuff outside of things. But it was always interesting in that way. And so like I had a lot of those experiences of like, I'm still learning Python and trying to employ lots of best practices. And as I look around, a lot of the stuff that's being created are just, scripts and things and so forth. So I definitely agree with you in the idea of like, okay, we wanted a locally hosted sort of Git tool. So we ended up setting up like a Git lab, and we started employing that. Testing wasn't something that we did a ton of, along with, again, something that somebody else mentioned there, a logging. Optimization is something that I felt like we slowly got into. And a lot of this kind of comes back to this conversation I had with Dane Hillard back in episode 49. He had his book, Practices of the Python Pro. I really like that conversation with him because, again, we've just had that thing about the survey and people coming out of school and having a year of professional experience. What you learn in school isn't necessarily what you're going to learn as far as like working with a team and becoming an actual professional and thinking about, well, how do I organize code and how do I even document code and take into ideas of like frameworks and scaffolding things that can be extensible or optimized and so forth. A lot of times it's just like, we just need to solve this problem. So I don't know, I'm kind of rambling a little bit, but that's kind of been my experience. Is it's, solving the problem first. And I think the things that can help in these circumstances is sharing some of these concepts. We would have these lunch meetings where we would get a chance to kind of share some of these techniques with each other. And so those were things like, at the time, this is the time when F strings were just coming out. So I was sharing that and saying, I think this is a much more elegant way of printing inside of Python. And so I shared that in one of our meetings and so forth. And just even communicating between the different parts of the team, which I feel like is a hard skill that needs to be there, but isn't necessarily part of a CS background.
Yeah, you mentioned the lunch and learn thing. For any team leads or managers listening, I am a huge fan of this. One, it gives people practice public speaking, which is something they almost always have to do in their job eventually.
Right.
But it's in a safe space because it's your team. It's on a topic that you pick, and you're generally going to know topics that are going to be interesting to your team because they're things you're working with each other on. It's a great way of gelling the team together. It's a great way of people getting a little bit of practice and sharing knowledge. And programmers tend to be very sort of meritocracy driven, right? So seeing each other having skill and value and helping each other, and that's really, really important.
I think it opens up the chance for people to ask questions of each other too, where they just, like, oh, this person does seem to know what they're talking about.
And never underestimate the power of free pizza to bring people together, right? So
exactly.
But you comment on something else. I had just finished reading John Osterhout's book called Philosophy of Software Design. If you don't know how Osterhout, he's among other things, he's the creator of the Tickle programming language. And the book talks about the art of designing good software, particularly how to get the levels of abstraction correct. And in the preface, he comments about the fact that he was never taught this in school. And I sort of went, yeah, neither was I. Yeah, you're right. And the fact was he went looking and there was remarkably little work about this topic. So he created a course. He teaches at Stanford, and he essentially tried to create a course around it, and he ran it for a few years. And the premise was, okay, you have a coding assignment, go code it. And then we're going to do a lot of code reviews. And we're going to talk about why did you make that design decision and how could you improve it and how do you iterate over it?
Yeah.
And the book essentially is an outcome of running this course several times and sort of his best knowledge. He's an old gray hair like us, and, things he's built up over years. And it's very, very practical, right? Like it's not, and there's no bandwagon stuff in it. Like, I don't think he even mentions microservices. Like there's an entire chapter on comments, right? He breaks down the idea of, the reasons people don't usually write comments, and essentially says these are bad reasons for not writing them, and talks about, but a lot of the comments that people do are bad comments. So how do we do that better? And where are they useful? Where should you do it? Where shouldn't you do it? That kind of stuff. So coming back to, the original question that Matt proposed, I think this is something we could all be better on, right? So some folks come by this skill a little more naturally than others, but Osterhout is right. It really just isn't taught, and it should be.
Right.
And instead of hopefully picking it up as you go along, actively seeking out how to get better at this turns you into a better coder. And if it results in your own code being easier to maintain, well, you're also one of the people who benefits from that, right? So even on your solo projects.
Yeah,
so
absolutely.
And and a big underlying premise in it is sort of this humble aspect of seek out reviews. There's this concept in the book of what we're trying to do is reduce the amount of complexity. And if somebody looks at your code and says that's hard to read, don't be offended, because if they thought it was hard to read, it was hard to read.
Right.
So then the question should be, did it need to be? And if not, how can you be better at it? Right. And I think coming from the CS sort of background space, it's very natural to go, well, I've got X number of years under my belt, et cetera, et cetera. Well, the data science folks are coming from a different space and they're bringing different skills.
Right.
And so we can figure out how to help each other with this. And if somebody who is junior is looking at your code and going, I can't read that, I don't understand it, rather than being proud,
right,
you're creating yourself something you're not going to be able to maintain, right? There's a high probability that what they're reading is future technical debt. So how do you get to a space where you're not doing that anymore?
I wonder how much technical debt is just simply, complex code and people just moving from job to job to job.
Completely. Completely. Well, and I can tell you, right? Like, if it was hard to write, 6 months from now, you will not remember how you did it, right? It doesn't have to have been, who was the idiot who wrote this? Oh, yeah, it was me.
It's always the get blame. Yeah. Pointing right back to you. Yeah. Yeah. I think it's a fascinating, area because I think educating people and sharing knowledge, and that's why I do what I'm doing. That's why I love doing the podcast, as far as asking questions of people and not feeling like, oh, I'm dumb for asking this dumb question. It's like, there is somebody who doesn't know, and I'm willing to take the hit of, seeming like I don't understand that thing to get it explained better again, and potentially try to go through the the mechanics of, well, how could this be explained? Maybe we could turn into an analogy or whatever ways to do that. Because I feel like there's a fear of trying to learn some of these things, and I just feel like that holy grail of like, oh, that person has a CS degree. It's like, yeah, but like in the end, we're all just trying to solve problems together and work together. And it doesn't necessarily have to be this wholly separate thing. I feel like there's so many little practices that can be instituted that can help bring everybody up and work better together.
Yeah, and this segues very, very nicely into my project this week.
Oh, okay. You want to go first then?
Yeah. So the tool I'm going to talk about is something called Radon. It actually came from an article by Mike Driscoll, a frequent contributor. We use his stuff all the time.
Yeah.
The article is titled Learning About Code Metrics in Python with Radon. So a code metric is a measure you can use to analyze your code. The simplest one most people know is the number of lines. Number of lines is not a great metric for a whole bunch of reasons, but it can act as a proxy for complexity. The more lines you have, in all likelihood, the more complexity you have. So Radon is written in and measures Python. It's built by Michel Latia and comes with 4 different commands. The first one computes the cyclomatic complexity, which is a measure of how many linearly independent paths there are through your code. So essentially, if you've got if clauses, the number's going up. The more if clauses you have, the more, especially nested ones, the higher your score gets. And as you think about it, it's kind of harder to understand, right? There's more things that need to be, this variable, that variable, and this variable all affect whether or not this code runs. So in the article, Mike runs Radon on the source code for Black, and this amuses me because some of the numbers are horrific. There's nothing like those opinionated guys at Black who are all nosy about how my code looks, getting a big letter F on their own code. It was a nice little Schadenfreude. So teasing aside, Radon gives you a summary of each of the functions or methods in a file, tells you if what it's processing is a function, a method, or a class, and then gives you a score. And if you like, you can also have a letter grade. And then you get a summary at the bottom, which the reports on things like the average score, et cetera. And that's just one of the 4 commands. The second one is called raw, and it outputs a whole bunch of really common things like lines of code, logical lines of code, lines of source, number of comments, number of multi-line strings, how many blank lines. So a whole bunch of just sort of counting the lines of things in your code and the different kinds of things.
Yeah.
And then there's 2 more that are in the tool that Mike doesn't cover, HAL and MI. So HAL is short for Halstead. The Halstead is a collection of different metrics based on the number of operations and the number of operators in code. And one of these is called the Halstead volume, which is based on the total number of operations times the log base 2 of the total distinct operations. And essentially, again, is one of those where a higher number is bad. And then the MI command is called the maintainability index score. And it's a complicated thing that includes the cyclomatic complexity, the number of lines of code, and the Halstead volume, essentially bringing them all together into a master score. So you always have to be careful because all of these things are proxies.
Yeah.
Fewer lines of code isn't necessarily better, but it doesn't hurt to get a sense as to what things are. And if you're trying to figure out how to improve, then, looking your own code with this can be useful. I've worked in a couple places where one of the things they've done is they've attached this to the commit check. And essentially the commit check would say, oh, if you made the Halstead volume worse, we're rejecting your commit. So it's essentially trying to put downward pressure on the simplicity of the code. Of course, your mileage may vary, but there's some neat ideas there. So I guess that leaves us last to your stuff. What's the project you're talking about?
Actually, I want to mention another episode. I've been throwing out tons of episodes this time, but we dove pretty deep into this actual topic that you're discussing in that. In episode 117, Rekha Horvath and Ben Martineau from Sorcery came on, and we talked about measuring Python code quality and simplicity and maintainability. And it was based upon their PyCon talk, which was titled Actionable Insights versus Ranking and How to Use and How Not to Use Code Quality Metrics, which I think is a good kind of tie-in to what you're talking about.
Yeah, there's a common commercial tool out there, semi-open source, called SonarQube as well, that often gets, it's got this as well as code smells and other things. I see that in a lot of my clients' spaces.
Yeah, they mentioned Anthony Shaw's thing called Wiley that is kind of cool too, which anyway, if you're interested in kind of digging into the stuff, that's a good conversation with lots and lots of links for you to dig into.
Cool. So what's your project this week?
I decided to do the simplest project I could find. I really like this one, actually. It's called words-tui, and we've been talking about TUIs a lot lately, the text-based user interface, and uses our friend Textual. It's an app basically to help you with daily writing, but just doing that in your terminal. Again, some people create writing environments that are just like no distractions, and I think a terminal is not a bad way to kind of approach that. It's by Anze Pekar. His GitHub is Anze, ANZE3DB. And if you're not familiar with the idea of daily writing, you can basically set a goal of like, I'm going to write this many words. And some people do it as a way to get prepared for, writing larger things like articles or blog posts, or just sort of dumping thoughts out of their brain, which can be actually a really kind of useful thing, or maybe it's a gratitude thing, what have you. This is a nice, simple app. You actually set your goal number. He has it defaulting to 300 words, but you can change it to what you want. It saves itself to a simple database inside of it, a SQLite database, but you could copy and paste the text out in case you like what you write. The easiest way to kind of get it going, in my opinion, is to use PipX to install it. If you're interested in learning more and more about PipX or installing these tools that are sort of terminal tools that you might use across the spectrum. Episode 101, I talked with Calvin Hendricks Parker about tools for setting up Python on a new machine, and we kind of focused on PipX quite a bit at the end of it to kind of set up these terminal apps. They're very easy to install and uninstall, and you don't necessarily need to have a specific virtual environment for them. The other reason I mentioned it is coming up soon is something called NaNoWriMo, the National Novel Writing Month. And this is one of those kinds of things where you would practice, like just stop, just write. And it doesn't necessarily have to be like all formatted, all pretty and so forth. Sometimes it's just a matter of getting in there and writing. So I thought words-tui might be handy there. And again, it's a nice, very simple kind of project app, or it might be a fun one for you to recreate something like it yourself. As someone who's writing a book right now, I don't know if you have any tools or other things that you've used to get in the practice of writing more.
No, I basically just sit down and bash my head against the keyboard and hope it comes out okay.
Yeah, it sounds like you've been working on some new chapters there.
Yeah, well, we should be having another one coming out in the next couple of weeks. So
sweet. All right, I'm looking forward to it. Well, thanks again for coming on the show and sharing all these articles and projects again, Christopher.
Always a pleasure.
All right, talk to you soon.
Cheers.
And don't forget, automatically find and fix vulnerabilities in your Python projects for free with Snyk. Create your free Snyk account at snyk.co/realpython. That's snyk.co/realpython. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.